Lesson 4.8 is on the quadratic formula, which maybe you're familiar with, and something called the discriminant. I'm guessing this is new if you're already familiar with the quadratic formula. So, just kind of to think again about what we know, we've been dealing with quadratic equations in all of Chapter 4. You've learned many ways to solve for x. You can solve for x by factoring. You've solved using square roots. Now you know how to complete the square. And quadratic formula will be the other way that you solve. And then just to remember again, what does it actually mean when you solve for x? We are finding those x-intercepts on a graph. Anytime you solve for x with a quadratic, you're finding your x-intercepts. Here's your quadratic formula. So please write that down. You have x equals, this is a negative b, plus or minus the square root of all of this b squared minus 4ac, all over, make sure this all over is underneath this negative b also, so the entire thing all over 2a. And we use the quadratic formula from standard form. If you notice, we have an a, b, and a c. And basically, we just look at our quadratic formula and plug in the a, b's, and c's into the quadratic formula. There are quite a few. I don't know if you guys know any quadratic formula songs, but if you go on YouTube and search for quadratic formula, don't get lost in how much fun it is to listen to all of those. But anyway, an easy way to remember it is through song, and quite a few examples you could look at on YouTube if you're interested. Alright, so let's just run through one of these. Use the quadratic formula to solve. Again, we do want to have everything on one side, 0 on the other side, and then just my advice has always been, let's keep the x squared term positive. So x squared, we'll subtract the 6x and add the 4, so we do end up with a minus 6x plus 4 equals 0 once we get those both to the other side. So, when we do the quadratic formula, we do want to know what our a, b, and c values are. So our a value is whatever's in front of our x, so our a value here will be a 1. Our a is in front of x squared. B is in front of x, which is going to be a negative 6. And c is that number off on the end, c will be a 4. So we just go to the quadratic formula, we plug those in. X equals a negative, and then negative b, so negative b, so a negative and then a negative 6, plus or minus the square root of b squared, so negative, not 6, negative 4, negative 6 squared minus 4 times AC. A is 1, C is a 4. All over 2 times A, which is a 1. Now when we go to simplify this, our negative 6 does become a positive 6, plus or minus the square root of. Now I always suggest, why don't we figure out what's underneath here, kind of off to the side. A negative 6 squared is a 36. And then the other thing I do, just because the common mistake I see with a quadratic formula is, should it be a plus or minus that goes next for these numbers over here? So I say I've got a negative 4 times a positive 1 times a positive 4. I know that's going to be a negative number, so I know I should have a minus. And then whatever 4 times 1 times 4 is, so 16. 36 minus 16 is 20. All over 2 times 1, which is 2. Now from here, what we want to do is see if we can do any simplifying. We've got these two terms, a 6 and the square root of 20, all divided by 2. So we can separate this up, because the 6 really gets divided by 2 and the square root of 20 gets divided by 2. So we'll say 6 over 2 plus or minus square root of 20 over 2. And now it just becomes a simplifying problem. Let me see if I can, that gives me more space. 6 over 2 is 3, plus or minus, now the square root of 20, if we think about that off on the side, that's going to break down into square root of 4 times the square root of 5. Square root of 4 is 2, so it's really a 2 root 5 over 2. So square root of 5, we can't touch that. There's no like terms with a square root. But do you see how we have this 2 over this 2? Those will simplify. If you had a 2 over a 2, those outside numbers, they would cancel. So really, we have 3 plus or minus the square root of 5. So quadratic formula, it's really not too bad at all to use. Here's where it gets to be kind of a pain, is in the simplifying piece, but not too bad. So the other thing that ties in with the quadratic formula is something called the discriminant. The discriminant actually comes right out of the quadratic formula. It's this b squared minus 4ac. So we take it right out of the square root, and all we do is b squared minus 4ac. Now what the discriminant will tell you is two things. You plug in your a, b, and c, you get a number, and it will tell you your number of solutions just by that one number. So if you were to, without having to solve all the way for x, it will tell you how many solutions there are. And remember, our solutions are your x-intercepts, so it'll tell you how many x-intercepts you have. And it also will give you the type of solution. Now when we say type of solution, you could have real numbers, but we also know about imaginary numbers, so maybe it's an imaginary solution. And your b squared minus 4ac, once we know how to read that number, will tell us those two things. So here's a handy little chart kind of going through your possible discriminants. So your discriminant, if your b squared minus 4ac is greater than 0, which means it's a positive number, you have two solutions and they are both real. So how many solutions are there? You're going to have 2, and they're both real solutions. What that looks like on a graph is your parabola is actually crossing the x-axis, and these two x-intercepts are the real solutions. If your discriminant is equal to 0, that means that you're only going to have one solution, but it will be a real solution, so a real number. If you look at the graph, that means you're crossing the x-intercept, or the x-axis is only in only one spot because there's one solution, which means your vertex must be right on the x-axis. That's that one solution. Now the other thing we have is, what if your discriminant, the b squared minus 4ac, is less than 0, which means it's a negative number? You still have two solutions, so how many solutions are there? There are 2, but these are going to be imaginary solutions. And then on a graph, what it looks like is your parabola is not touching the x-axis at all. So it could be up there, maybe it's down here somewhere. You have no x-intercepts if you have a negative discriminant. So when you're asked to find the discriminant, they also will want to know the number and type of solutions. So you do want to get everything on one side, 0 on the other side. So we have 7x squared minus 2x minus 5 equals 0. This allows us to identify our a, b, and c. Our a value is 7, our b value is a negative 2, and our c value is a negative 5. So when they say find the discriminant, that means we do our b squared minus 4ac. Our b is a negative 2, so negative 2 squared minus 4 times a is 7, and c is a negative 5. So a negative 2 squared, remember anytime you square these numbers, they will always be positive, so we have 4. And then here's where we have a negative number times a positive times a negative. I know that will end up being positive, so plus. And then whatever 4 times 7 times 5 is, I believe it's 140. 20, yep. And we add those and we get 144. So the discriminant is 144. So what does that tell us about our quadratic? Well, it's a positive number because this is greater than 0. I know that there are two solutions and they are both real numbers, so 2 real solutions. This graph, if I were to draw this parabola, I know that I would be crossing the x-axis in 2 spots because I have 2 real solutions. So that's what your discriminant is. You just find the number, and then whether it's a positive number, a negative number, or equal to 0, that will tell you how many and the type of solution that you have.